Welcome to A-Level and AP Physics. In this lesson, we will discuss important past paper question on capacitance from May-June 2021, paper 4.1. For part A, simply we need to state what is meant by the capacitance of a capacitor. In order to understand capacitance, we need to understand Q is equal to CV. Q is the charge on single plate, or simply we can say this is the charge on one plate of capacitor. Simply we can say charge on one plate. C is the capacitance of a capacitor, and capacitance simply means that this is the ability of a capacitor to store energy. If the capacitance of a capacitor is greater, it means capacitor is able to store more energy. If the capacitance of a capacitor is lower, it means capacitor is not able to store a lot of energy, or simply you can say it has ability to store less energy. So this is about capacitance. Let's try to understand what this symbol is representing. This symbol is for the potential difference between the plates. Simply we can write down potential difference between the plates of a capacitor. So this is potential difference. We can also understand with the help of the symbol of capacitor. So this is the symbol for parallel plate capacitor. Let's say this plate is positively charged and this plate is negatively charged, and the net charge on this plate is plus Q, and the net charge on this plate, this is negative Q. So this Q simply means that you need to take the charge on one plate. If we look at the charge on these two plates, the net charge on these two plates, the net charge on these two plates means the net Q, that is plus Q minus Q, that is equal to 0. So it simply means that capacitor does not store charge. Capacitor store energy. Very important point. Now what does it mean by the potential difference? Potential difference simply means that this is the potential difference between these two plates, and you can find out this potential difference by simply connecting voltmeter across these two plates, or simply between these two plates. This is what you need to understand about capacitance. Let me explain to you how you can write a proper answer to get 2 marks for this question. In your answer, first thing you need to mention that capacitance is equal to charge over potential. You can also say charge over potential difference. If you have mentioned this one in your answer, you will get 1 mark, and this is M mark. It means that it must be in your answer. The second, in order to get the second point, you need to mention charge is on one plate. Simply means that you need to explain what do you mean by charge here. Then you need to explain what do you mean by potential. So potential is the potential difference between the plates, and charge is charge on one plate. As I have already explained to you, the Q is the charge on one plate and V is the potential difference between the plates. From here, simply you can write down C is equal to Q over V, and then you need to explain what is Q, what is V. So the Q is charge on one plate and V is potential difference between the plates. For part B, it is given to us a capacitor of capacitance capital C is connected into the circuit as shown in figure 7.1, as you can see here. It is also given to us when the two-way switch, means this two-way switch, it is in position A, the capacitor is charging, means when it is connected like this. The capacitor is charging, and when this capacitor is fully charged, the potential difference across capacitor is equal to the potential difference across the power supply. Simply, it is equal to capital V. But when we move this switch to position B, this capacitor will start discharging. Question is asking us B1. For B1, we need to show that the average current in the ammeter is given by the expression I is equal to FCV. In order to prove that I is equal to FCV, we can simply start from Q is equal to CV. Now if we divide both sides by T, and T is the time taken for a capacitor to charge and discharge, then simply you can see on the left side we have Q over T, and Q over T, this is equal to I. If we look at right side, we can also rearrange. We can write down like this. Now 1 over t, this is simply, you can understand, 1 over time period, and that is equal to the frequency. We can write down small f. So finally we have got I is equal to FCV. This question has 2 marks. This derivation you have included Q over T, you will get 1 mark, and that is M1 mark. This must be in your derivation. And the second mark you will get if you have got this correct answer, and that is A mark. For part B2, it is given to us the potential difference is equal to 150 volts and frequency is equal to 60 hertz. Average current in the ammeter is given, that is equal to 4.8 microamps. We need to calculate the capacitance in picofarad. This question is pretty straightforward one because it is just simply based on part B1. In part B1, we have derived this expression I is equal to FCV. Now this question is asking us to calculate C, so we can rearrange this expression. We can write down C is equal to I over F times V, and we can plug in values. I is given, the value of I is 4.8 times 10 to negative 6 amps, and this is divided by the frequency. Magnitude of frequency, or simply the value of frequency, is equal to 60 hertz, and potential difference is equal to 150. Now if we solve this one, we can get the value of capacitance. That one will be equal to 530 picofarads, and that's the final answer. Simply we need to write down 530 picofarad. This question has 2 marks. The first mark you will get the C mark if you have rearranged this equation and you have plugged in these values, and the second mark is A mark. This is answer mark you will get if you have got the right answer. So there are 2 marks for this question. Even if your answer is wrong but you have written this one, you will get C mark. But if you got the right answer, you haven't written in this way, still you will get 2 marks. So it is very important to show your working. Even your answer, for example, for this part is wrong, but you have shown this one, so you will get 1 mark. So always write down the formula, then show your working and plug in values. For part C, it is given to us a second capacitor having the same capacitance as the capacitor in part B is connected into the circuit of figure 7.1. The 2 capacitors, they are connected in series. We need to state and explain the new reading on the ammeter. In order to answer this question, the first thing we need to understand, when we connect another capacitor in series with the first one, what is the total capacitance of this circuit? As these 2 capacitors, they have the same capacitance, they are identical and they are connected in series, so the total capacitance of the circuit, that will be equal to C by 2, means it becomes half. But the potential difference is the same, so simply we can understand then from Q is equal to CV, we can write down the C is equal to Q by V. But V is the same. If C become half, it means Q also becomes half. So this is the main point we need to understand. Now we can understand I is equal to Q over T, and if time is the same but the charge is half, it means I is half. We can also understand this one simply from the formula we have already derived. I is equal to FCV. In this case, F is the same, V is the same. If the C become half, it means I becomes half. That's all what we need to understand. It simply means that current will be half. Before, the value of current I naught, that was equal to 4.8 microamps. Now it becomes half. It simply means new value of current, this is equal to 2.4 microamps, and charge is half because capacitance is half, or you can say current is half because capacitance is half. You can also explain this one. You can say as
F and V, they are same. When the capacitance becomes half, I also becomes half. That's all what you need to understand and you need to write down to answer this question. Now let me explain to you how you can write a proper answer. This is how you can write a proper answer. The first point, if you have written 2.4 here, you will get 1 B mark. The second B mark you will get if you have written total capacitance is half. The third one you will get if you have mentioned charge becomes half. Or you can say F and V are constant, current becomes half. Or you can say current is proportional to capacitance. That's all what you need to write for this question.